All right, so for the next question, which is from 2017, I moved this down a little bit too fast. Yeah, 2017. They're asking about relationships about wolves. And so they were measuring the length from tip to tail and compare that to the weight of the wolves. And so the scatter plot of weight versus revealed, there's a relationship between two variables described as positive, linear, and strong. Okay, so remember, you kind of have to talk about which direction the relationship is. Is it linear or not? And then also, or is there some other pattern that's showing up? And is it strong, moderate, or weak? And that depends on how closely tight to that least squares regression line is. Okay. So they go through and they ask you, what does positive mean? What does linear mean? And what does strong mean? So positive relationship, and this I found interesting because I don't know if I would have necessarily done it until I double checked the answer rubric. Okay. Positive relationship would mean that the wolves who are longer in length would also have a greater weight. So it's not just a matter of saying, okay, the data is really tight, etc. You want to say, since it's or like as one goes up, the other goes up. You want to kind of give a specific in context. And again, that's the one thing. I don't think you can go wrong by relating it back to the original problem and putting things in context. So make sure you do that. The linear relationship, this is the one which I find interesting. Would mean that the data shows that as a wolf's length increases by 1 meter, the weight would increase by a constant amount on average. Okay, so again, linear being, it's forming a line, there is going to be a slope. So as you're saying, since slope is always over 1, you're talking whatever your x coordinate is. So in this case, length is one length happens, the weight's going to go up a set amount. We don't know what the set amount is. That's fine. But again, refer to it that one length. As that x value increases by 1, there's going to be a set average jump that you will see in the data there. And the strong relationship just obviously makes it a little bit easier. And again, as I said earlier, strong relationship indicates that all the data points are going to be when you plot them, are going to be very close to being a straight line. So there's a very strong relationship. It stands out. In part 2, they go off and they will say, okay, what happens if we give you this least squares regression line? So again, go back and define, make sure you know what x and y are. X is being length, y is being weight. And so the slope, which is right here, the 35.02. Now go back to your algebra 1, okay? Think back to algebra 1. And so remember, slope is just going to be y over x, right? So what is your y variable and what is your x variable label? The y variable is going to be kilograms. The x variable is going to be meters. So it would indicate that you're talking about 35.02 kilograms for every meter of length. All right. And I'm not trying to say, hey, I am trying to say this is super easy. This is stuff that we, at least at our school, deal with. Like my algebra classes, we deal with this all the time. Everything's in context. We throw out the slope and we talk about what it means every single time. So again, go back to that definition of slope being y over x, and you should be fine. And then last but not least, one wolf pack has a length of 1.4 meters and it has a residual of 9.67. So here they're trying to get to, do you know what a residual is? So what was the weight of the wolf? So again, we've got the formula here. We're going to go through and talk about we're going to find the predicted weight. So if we put in 1.4 meters here, we would expect that the weight would be 32.57 kilograms. Since residuals are actual minus predicted, we know that a -1 is going to be below the line. All right, which means that our value should be less than that 32.57 kilograms. So we're going to go ahead and add on that negative 9.67 kilograms onto the weight, which is what I got down here. And I get, oops, I thought I was in highlighter mode. It's going to be right here. Okay. I would guess you'd probably be okay with that, but I went ahead and wrote out before I checked it some context here. So a residual of 9.67 kilograms would correspond to an actual weight of 22.9 kilograms for a wolf 1.4 meters in length. When you do that, just refer back to what the height is or what the length is, because obviously you need an X and a Y. And there's a lot of different, the wolf could weigh 22.9 kilograms and be on the line. So we don't know that. So that's why I put that there.